Hello guys, right, we've got a couple of lessons now which are really important, okay? We are going to draw graphs, as I said earlier this week. We're going to draw, you guys are going to draw graphs for sine, cosine, and there is a temptation to just skip that, but I really think, you must not think, I know you must do it. So I'm going to give you like a little, maybe either you'll do it on the lined paper or I might provide you with a graph paper. However, you can't really print it. So I'll provide graph paper. If you don't have print facility, it's not a big deal. You just draw it, you sketch it. Okay? But I want to just talk about something we did last lesson. We said that solutions for trig equations, there's always two of them. So if, for example, we had sine 30, that was half. There was another solution, another angle, instead of 30 that will do that. And we did that by doing 180 minus 30, so 150 is also half. If you put sine 90, okay, we will kind of try and understand that today, but until now, just put in the calculator, you'll get 1. But you'll see there's only really one angle that'll give you sine x equal 1. There's no other angle that will do that. Okay? So how is that possible? I mean, I said there's always two angles will give you the same solution. Okay? So why is there only one now? Well, just try and find the other one. Okay? How do we find the other one? The other one, okay, is going to be, if sine x equal 1, and we know that's x equal 90, the other solution must be 180 minus 90, right? That was the rule we learned. But what is 180 minus 90? It's 90. Okay, so we're getting the same solution. You can find the same angles, say, for cosine. So cosine, okay, the angle that only have one solution is 0. Okay, you can try and figure out what that is. Well, actually, you won't figure out. It will be a bit confusing now. Let's just leave it at that. Okay, that was a little aside. Let's go back to our proper lesson. So what I'd like you to do now, okay, write down the table. We're going to vary the angles, the theta we'll call it, the angle in theta, 0, 30, 60, 90. We're going in 30s all the way to 360. And what I want you to do is use a calculator and find out the answer, not in the surd form, in decimal places. Okay? So write it down, okay? 0, if you put sine 0, you will get 0. If you put sine 30, you'll get 0, 0.5. Okay? So on and so on and so on. Write down that table. Now, if you can print the graph paper that I'll send you, then print the graph paper and draw a graph. Okay? You'll have theta here as your x-axis, and that's your x, and your y is sine theta. Just draw that graph, all these points. If you don't have a graph paper, nothing to worry about. Just draw it in your book as well as you can. It really is important. Just pause me now, okay, and do that. Okay, I'm waiting for you. I'm not going anywhere. Take your time, okay? There's no homework, no exercise. This is the exercise to do, okay? So pause me. Great, okay. Now, hopefully what you've got is something like this, that wavy graph that I showed you already last lesson. But it really, I'm emphasizing, it's really important that you're actually going to do it. How are you going to do it? Okay, so you should have at 30, at 60, at 90, at 120, at 150, at 180. You put these points, points. Okay? Put these points. Okay, just like we do in science, okay? And then we just draw a line, like we draw a line base fit. You've got this nice wave here. You do it also all the way to there, all the way to 360. Okay? Just join a line. You get that wavy thing. And before we move on to the cosine, I want to just think about specific points here. If I had my purple, I would get my purple. Use the green. Okay. So I want to look at specific special angles. Not actually at 30. I want to look at 0. I want to look at 90. I want to like 180, 270, and 360. Okay? And I want you look at these angles in terms of that circle that we had earlier. Okay? Remember that we've got a triangle. Okay? The radius is your hypotenuse. Okay? The opposite side is your y coordinate, and the adjacent side is the x coordinate. And sine, this is theta. So sine theta is always, whatever you are on this, whatever quadrant you are, it's always the the opposite side, the y coordinate divided by the r. Now, when y equals 0, okay? Sorry, not y, when theta is 0, that means this angle is 0. So this is where the point is, okay? This is at 0. Okay, the sine theta is y over r. So what is y? When the point is here, what is y? Well, y is 0. Okay, a point here, if this is the x-axis and this is the y-axis, the y here, it's x-intercept, so the y is 0. So 0 over r is going to be 0, and that's why we got 0 here. Okay, I'm trying to explain some special angle, which is really important that you understand. Okay, now let's have a look at it's 90. Okay, 90. Where is 90? Here. This point is 90. Here, theta is 90. Here, theta was 0. Okay? Now, if I was to draw this triangle, I'll move that circle, move that circle, move that circle. Okay? Okay, this is your r. What is your y here? What is the y coordinate? Your y coordinate is the same as the r. It's the whole radius. So the y coordinate here, okay, is going to be y over here, right here. Y equal r. That means sine theta is y or r over r, and it is 1. Okay? The y and the r are the same here. So sine theta is going to be 1. Or sine 90 is 1. Okay? That's why here it's 1. Sine 0 is 0, sine 90 is r. It's so important to understand that, guys. Please ask me if you don't get it. I'll talk to you independently, or maybe even send another video for the whole class. Let's move on to sine of theta equal 180. Okay, so we're drawing another triangle here. Okay, I can't really draw the triangle because it's the same line here. Okay, sine theta is y over r. So we need to ask ourselves, what is y? What is the y coordinate here? Well, we're crossing again. Okay, we're crossing again the x-axis. It's an x-intercept. So the y, the value of y, is 0. So sine 180 is again 0, as you can see here. Right, I'll write it down here. I'm not moving to 180, it's 0. Next stop, okay, we're going to move to 270. Okay, this is theta equal to 70. Now we're drawing this triangle here. Okay. Again, sine theta is always y over r. So I've got to ask myself, what is the y? What is y equal here? Okay. Well, y is exactly minus r. I don't know if you can see it. You can't see it. You see the 270? You can. Kind of. Theta is 270. So here, y is equal to minus r. It's negative r. Here it was positive r. Here's negative r. So what will be sine 270 if it's minus r divided by r? It's going to be minus 1. So over here, swings to minus 1. Okay? Now we're moving back to 360. Okay? Now check this out. This is a bit funny one. What is theta equal 360? Well, we got exactly to the same point where we started. So 360 degrees and 0 degrees, that's really the same thing. It's absolutely the same thing. How crazy is that? 0 and 360 is really the same angle. We just did a whole revolution, but we start where we came from. So we're at the same point. Okay? So what is going to be y equal here? Okay? What is the y coordinate at 360? It's theta equals 0. We already mentioned that. The y coordinate is 0. So sine 360 is also 0, and it goes back here. Guys, I cannot emphasize how important this lesson is. To really understand why sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 is minus 1, sine 360 is back where we started from. Okay? Really, 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 really important. Okay? Please take your time, listen to this, and like I said, it really is important that first, before you listen to my explanation, you draw this graph. Okay, we're going to do the second video on cosine.